Hey guys, Mr. Casares here, and we're going to go ahead and work on this worksheet together. So make sure that you have this worksheet in front of you before you get started with this video. Alright, so first we're going to go ahead and do a review of last week's material. So questions 1 through 4 is all from last week, okay? So what I want you to go ahead and do is pause the video right now, try number 1 through 4, and once you've done that, go ahead and play this video to see if your answers are correct. Okay, hopefully you tried out those questions and now you're ready to see if you're right or wrong. The first one, now, before I even get started, it's very important that you read these carefully. Okay, a lot of the mistakes that happen are because we don't read it carefully or we just skim it and we look for numbers and words, right? And that's how we make mistakes. So it's very important that you take your time and read it carefully. Number 1, the probability of randomly selecting an ace or diamond card from a deck of 52 cards is 16 out of 52. So right here when we say standard deck, just in case you didn't know, a standard deck has 52 cards. That's what it means to be standard deck. So now the first thing you need to ask yourself is, what is the outcome? Or is there more than one outcome? What are we hoping that happens here? Okay, so what we're looking for is the probability of randomly selecting an ace or diamond card from a standard deck. So we're going to go ahead and write this as the probability of randomly selecting an ace or, so the symbol for or is this one here, or diamond card, and that is 16 out of 52. Now, if we convert that to a decimal, we're going to go ahead and write 16 in our calculator. 16 divided by 52. We're going to get 0.3076, and it keeps going on. So what we're actually going to do is round to 3 decimal places. So 1, 2, 3. So we're going to round there. And we actually have to look at the number that comes after that. So the 6 will determine if we bump up the 7 or leave it alone. And actually, because the 6 is a 5 or bigger, then the 7 does indeed get bumped up to an 8. That's how we round to the 3rd decimal place. And now we're going to convert that to a percentage. And the way that we're going to do that is by multiplying by 100. Okay, so if we do that, we're going to get 30.8, and don't forget your percent symbol. All right, now before we move on to number 2, there's some things we have to talk about. This symbol here is not a capital U like some of us have been writing, okay? So don't write that. Okay, it's not like this either. Right? I've seen all this. It's actually a math symbol, okay? It's not a letter, although it looks like one. And what this symbol means is OR, but the name of that symbol is a union. So that symbol has a name, and it is called a union. So from now on, I'm going to be calling this symbol a union. Okay, so let's go ahead and go to number 2. The probability of Mr. Casares randomly selecting a student from his 5th period that sits in group 2 and is a boy is 50%. Now, immediately, if you just skim this, you might say, okay, selecting a student. Okay, so probability student, and then you might say 50%, right? And that's wrong because, yes, we're looking for a student, but we're looking for a specific type of student. We're looking for a student that sits in group 2 and is a boy. So that is our outcome. Okay, so we're going to go ahead and write that. Probability of a student sitting in group 2. And, so this is the symbol for and, is a boy. And that is 50%. Now, 50% is our answer here, and written as a decimal, it would be 0.50. Okay, now, one thing I need to talk about is this symbol right here. Okay, I've seen a lot of us in our quizzes write this as a N, so you'll do something like that, write it like an N, or you'll even write it like a capital N, and both of these are not correct, okay? That's not how we write them. All right, we just write it like almost an upside down U, just like that, okay? And this symbol means and, right? So we know that much. But it actually has a name, okay? And that name of this symbol is an intersection. All right, so from now on, I'm going to go ahead and start calling these symbols a union and intersection. And you have to know that a union means or, and an intersection means and. Okay, so we're going to go ahead and go to number 3. The probability of failing a quiz given you were absent all week is 75%. All right, so let's go ahead and highlight the outcome. So here, the probability of failing a quiz is an outcome, but we have a little bit more information. We were given that you were absent all week. So not just probability of failing the quiz, but failing the quiz given you were absent all week, which means you were absent all week and then you took a quiz, right? And the probability of that happening is pretty high. It is 75%. And I hope that makes sense to you, because if you're absent all week, then yeah, we would probably expect that you wouldn't do too well on the quiz, okay? So let's go ahead and write this. We're going to write the probability of failing a quiz now, given is this symbol, given you were absent all week. So absent all week. And that is 75%. And as a decimal, that is 0.75. All right, so very likely that you are going to fail a quiz if you're absent all week, and I hope that makes sense. Okay, so that's what this line means. The line right there means, this line means given. All right, and the last one, the probability of selecting a card that is not a queen from a standard deck of cards is 0.923. Now, if you read this quickly and not carefully, you might have said the probability of selecting a queen, or you might have put the probability of not a queen. And actually, both of these are not what we're looking for, okay? This first one's completely wrong. The second one is pretty okay, but the correct way to write this would be the probability of selecting a card. Remember, our outcome is not a queen, so we would write queen, and then we put the little C right there. And that is 0.923. And as a percentage, it would be 92.3%. Now, how you read this is the probability, remember, this means not a queen or anything but a queen. Okay, that's what that little C means, anything but a queen, not a queen. Okay, and actually that C, yes, it means anything but it has a name as well, and that's why we use the letter C. It is called a complement. And no, it's not a compliment like your shoes are nice, right? That's spelled differently. This is a complement, which means anything but. Okay, so it's a different type of complement and it is spelled differently. All right, so that's review from last week. We're going to go ahead and jump to the new stuff. And this new stuff is about complements. Okay, so we're going to look at complements a little bit more closely. All right. For this, the rest of this worksheet, we're going to be using this wheel here to answer the questions. So let's go ahead and read the example. Alfredo is at the Madeira Fair and is playing carnival games. The game he wants to play is called Wheel of Luck. Whatever the wheel lands on is what he gets. So if he spins the wheel and it lands on no prize, then he gets no prize. If he spins the wheel and it lands on stuffed animal, then he'll get a stuffed animal. Answer the following questions and write your answers in probability notation. So make sure you write everything in probability notation. Okay? So I'm actually going to have you guys pause the video right here. Try these 4 out. Okay? And then when you're done, go ahead and play the video to see if your answers are correct. I am expecting this to be a little bit tougher than the questions above, but still try it out before you watch the video. Okay, so go ahead and press pause, and when you're done, come back to see if your answers are right. All right, hopefully you tried those out. Let's go ahead and answer these. Number 1, find the probability that Alfredo's spin does not land on free spin. Okay, so let's talk about what the outcome is here. The outcome is not free spin. Okay, the outcome is does not land on free spin. Okay, so how would we write this in probability notation? We're going to write probability of free spin, but we don't want it to land on free spin, so we're going to put complement. Okay, so what this means here is anything but free spin. All right, so the complement of free spin, anything but landing on free spin, does not land on free spin, right? These are all the same thing, and that's how you would write it. Now, we don't have the answer like we had up above, so we're actually going to have to find it ourselves. So if we look at the wheel on the left, we want it to land on anything but free spin. Okay, so let's look at how many spaces will give us anything but free spin. So this one works, this one works, oh, this one does not work, this one works, that one works, nope, and that one works. So we see that we have a total of 6 spaces that will give us anything but a free spin. And that's 6 out of 8 spaces in total. Now, if I convert that to a decimal, I'll grab my calculator and do 6 divided by 8. And that is 0.75. Now, as a percent, again, I would multiply by 100, and I will get 75%. All right. So let's go ahead and do number 2 now. Find the probability that the spinner does land on free spin. Okay, so now we actually want it to land on free spin. So we're going to write the probability of the spinner landing on free spin, and that we're going to go ahead and calculate that. Now, there's 2 ways to do this problem. The first way is using the picture that is given to us, and that's probably the way that we all did it. So we want it to land on free spin, so we see that we have 1 and 2 free spins. We only have 2 free spins on the wheel, so it's 2 out of 8. And if I convert that into a decimal by doing 2 divided by 8. I will get 0.25, and that as a percentage would give me 25%. Now that's one way of doing it. The second way is actually what I want you guys to understand from this video, and this is a very important idea. So make sure that you're listening right here. Let me give you an example. Let's say that you're playing a game and there's only 2 options. Okay, so there's only 2 options. You either win or you lose. There's no tie, okay? So you're either going to win the game or you're going to lose the game. Well, I know that the probability of winning is, let's say, 40%. That's what they tell me. Probability of winning is 40%. Well, what's the probability of not winning? Well, the probability of not winning, remember, this little C right here means not winning. So let me put it in this pink color, that way you can see it. This means the probability of anything but winning, okay, or the probability of not winning. Well, hopefully you realize that if the probability of winning is 40%, then, and you only have 2 options, well, then the probability of not winning would be 60%. Right? And hopefully you notice that these 2 numbers, when we add them up, give us 100%. Okay? So again, the probability of, by the way, not winning in this case would be the same thing as losing, right? So we could write this as a probability of losing is 60%. Okay, so these 2 here are the same thing in this example. But the main idea I want you to understand is that if we have the probability of something and we want to find the complement of that, well, we can just look at the answers and realize that they need to add up to 100%. Right? So now let's go back to our example. The probability of the complement of free spin was 75%. And the probability of free spin, so the opposite, is 25%. And if we look again, these 2 do add up to 100%. Right? So that's another way of doing it without the picture. If you have one of them, you can easily find the other one because you know that the percentages should add up to 100%. Okay? Same thing with the fractions. The fractions should add up to 1. And I will show you that that's true. So 6 out of 8 plus 2 out of 8. Remember, when you have 2 fractions and the denominators are the same, you add the numerators. So 6 plus 2 is 8, and you leave the denominators alone. So 8 out of 8, well, that's just 1. Okay? It'll also work with the decimals. So let's say I get the 2 decimals and do 0.75 plus 0.25. Well, that's just going to give me 1. All right, and like I already showed you, it works with the percentages too. 75% plus 25% will give you 100%. Okay, so all these things, when you have the complement of an outcome and you want to find the outcome, well, we know that these 2 have to add up to 100%. If it's not this one, it's this one, right? If you're not winning, you're losing. So when you only have 2 options like that, they should add up to 100%. So let's go ahead and see that in this next example. Find the probability of Alfredo's spin landing on anything but stuffed animal. So the outcome here is anything but stuffed animal. So we're going to go ahead and write this as the probability of, and I'm going to write stuffed animal, but we want anything but a stuffed animal. So we want the complement of a stuffed animal. And the complement of stuffed animal, or not landing on stuffed animal, or anything but a stuffed animal, right? These are all the same thing. Let's go ahead and go to our wheel. I want it to not land on stuffed animal. So let's see how many choices I get. This one doesn't work. That one works. That one works. That one works. That one works. All these work except that one that says stuffed animal. So the probability that when you spin the wheel, it will not land on stuffed animal will be 7 out of 8. And as a decimal is 0.875, and as a percent is, if we multiply by 100, 87.5%. Now, that's for the complement of a stuffed animal. Anything but a stuffed animal. Question 4 is asking us, what is the probability of Alfredo's spin landing on a stuffed animal? So now we actually wanted to land on a stuffed animal. Well, again, there's two ways to do this. If we have the picture, we can look at the picture, right? But let's just pretend for this example that we do not have the picture, right? So let's ignore the picture for now and just try to do this example by looking at number 3. Okay? We know that the probability of stuffed animal, anything but a stuffed animal, is 87.5. Well, then the probability of stuffed animal, whatever this is, has to add up to 100% together. So if I figure that out, I'm going to get that this has to be, if I do 100, so I'm going to do this off to the side so you guys can see. If I do 100%, because they need to add up to 100, and I already have 87.5, so I'm going to subtract that. And that will give me 12.5%. So without even looking at the picture, I already know that the answer to this question is 12.5%. Because I know the probability of it not happening, then I can figure out the probability of it happening. Okay? That's how complements work. If you know one, you can figure out the other. All right, so now let's go ahead and, now that's the percent. Let me go ahead and do the same thing with the fraction. Well, I have the fraction right there. I know the complement would be 7/8. So 7/8 plus something has to give me 1. Well, that's 1/8. Because 7 plus 1 will give us 8 out of 8, and that is 1, right? So I know, again, without having to look at the picture, that the answer here would be 1/8. And same thing with the decimal. If I have the decimal, I know that they should add up to 1. So 0.875 plus something needs to give me 1. Well, that would be 0.125. So 0.125 would go there. Okay, so what I'm just trying to tell you is if you know one, you know the other. Okay, if you know the complement, then you can find the other one. Okay, so hopefully that makes sense. I want you to go ahead and now try number 5 and number 6. And when I get back to class tomorrow, I will check these first thing. Okay, so make sure you give these a try. It's okay if you get them wrong, but I really want you to try this out. All right, if you have any questions, write them down so you don't forget, and we can go over it when I come back to class. All right, have a great day.